Yes, thank you, students. Today I am going to explain you the simplex method. Uh, you know that this is another way of solving the linear programming problem. Here, maximize z equals 2x1 plus 3x2 subject to x1 plus x2 is less than or equal to 1. 3x1 plus x2 is less than or equal to 4, where x1 comma x2 is greater than or equal to 0. Now step number 1 is that is standard form. So given constraints, you add slack variable here, x1 plus x2 plus s1 equals 1. Second constraint equation is 3x1 plus x2 plus s2 is equal to 4. So these two are constraint equations added with slack, and this less than or equal to becomes equal to. Then all these variables x1, x2, s1, s2 are all greater than or equal to 0. Now these two slack variables you add with the what is called objective function with 0 coefficients, 0 into s1 plus 0 into s2. Okay, and this whole process we call standard equation. Now come to the modified form. Modified form is nothing but changing all the variables one side and constant on the other side. See there in the screen, you see the left hand side we have the constants, whereas in the right hand side you see the variables, such that each and every equation should have the variables there. Such a way we are writing, that's called modified form. The next step is simplex table. The simplex table is nothing but all the variables involving in these equations are written at the top. Then a table is followed, see on the screen. Okay, so under that particular variables, what are the coefficients are coming here, we are writing there. Okay, minus 2, 1, 3, minus 3, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 4. And the basic variables to get that, look at that, some variables are in canonical form, s2, z, and then s1. So these are in canonical form. Those are called variables. Okay, this is a third step. Fourth step is the test for optimality. The given function is objective function, which is maximization. Look at the given problem there. That is maximization problem. Okay, so our see this simplex table in equation 1. The z objective function consists of two negative numbers. The two negative numbers damages our object. Therefore, the maximum negative number we try to make it 0 by making this a canonical form. Okay, so incoming variable, I mean the variable which is going to come in the canonical form is x2. Now to come this inside, this any one of the canonical form is already existing should come out, s1 or s2 should come out. So what is that? So minimum replacement ratio we are finding out here. The minimum replacement ratio is Ci by Xi. Ci is the constant variable coefficient, and Xi is the corresponding variables coming in the incoming variable column. So here 1 by 1 and 4 by 1. Among this the minimum is 1 by 1. So the minimum replacement ratio is 1 by 1. So intersection of the incoming variable and the outgoing variable is called pivotal element. Here the pivot element is 1. So we are lucky to have this, the number 1, because if the pivot element is not 1 but any other number, then we have to make it 1 by dividing that number throughout this equation number 2. Now coming to the next slide. Okay, we will come to the next slide now. Look at this. This is next simplex table, where you go back here, and to make it here one already is there. Using this equation number 2, we have to make it 0 here, and we have to make it 0 here. For that, if you apply this particular rule, definitely you will get 0 here, you will get 0 here. I mean, multiply equation number 2 by 3, add with 1, you will get an equation number 4, and that is what this. Similarly, multiply equation number 2 by minus 1 and add 3, you will get equation number 5. If you do so, this x2 will be coming in canonical form. Okay, look at the table there, right? And this table consists of the canonical form in S2, Z and X2. See here, X2 and then S2 and Z. So these are the basic variables. Okay, now next step is test for optimality. We know well here Z is object is to maximize the function. So maximization means all the numbers should be here positive or 0. We see that all are positive and 0. Therefore, the optimum is reached. Here the maximum is the optimum that is reached. Now the solution set here is the base variables coming here is the basic variable. Those are not coming here are not basic variables. Take for example, x1 is not coming here. It is a non-basic variable. x2 is a basic variable. It has the value 1. s2 is a basic variable because it has the value 3. s1 is not a basic variable. Its value is 3. So x1 is equal to 0. x2 is equal to 1. s1 is equal to 0. s2 equals 3. Now substituting these values in the original function, we know what is original function is maximum z equals 2x1 plus 3x2. Now look at that. Substitute that value in that particular equation. You will get z equals 2x1 plus 3 into x2 plus 0 into s1 plus 0 into s2. Substituting in that, you will get 2 into x1, the value is 0, plus 3 into x2, the value is 1. So maximum z equals 3. And this is what the answer for our problems. So whatever may be the problems given, these steps are very important. Standard form, modified form, simplex method, test for optimality, and then incoming variable, outgoing variable. Next simplex table, the same method. Then test for optimality. If it's satisfied, this will give you the basic solution for our problem, and substitute those basic variable values in our given maximization problem, and that will give us solution for our problem. So thank you very much for listening to me. Thank you.